Hi guys, what I'm going to do is I'm going to have a look at the commands for week 3. Now I'm doing it slightly different this week purely because there are some explanations that go along with the commands themselves. Okay, so I can't just do a demonstration video. However, there will be screenshots here that I will explain. Okay, so similar to previous past 2 weeks, this is just a demonstration reminder. And have a look at any of the exercises and manuals that are there. And remember, this is case sensitive. So the first thing we have to do is we have to set up our files for week 3. Okay, so the command we've got here is mkdir week 3. So mkdir week 3 will create a directory called week 3. Then underneath that, the command is cd space week 3. So what we're doing is we're moving inside the week 3 folder. And then what I'm going to do is I'm going to copy CP from the root, the exercise folder, and inside the exercise folder, I'm going to copy everything that ends in .txt. And I'm going to put it in tilde. If you remember from last week, tilde is your home directory. So we're going to put it in tilde / week 3. So that copies all of the files inside exercise and copies them across to week 3. So to prove that, what I'm going to do is type ls, and you can see that you have got the files that we used last week, and this time they're placed inside week 3. Okay, so we've already seen this. We've already seen that you can look at the permissions for any files or folders located in any directory. So ls-l will show us the file permissions for the files and folders that we have. So the first dash here, that indicates if it's a directory or not. If there's no D in there, then it's a file. Then they come in groups of 3. So we have got RW dash. So that first RW dash is the permissions for you, the user. Then we have R dash dash. So R dash dash is the group permissions. And then we have everyone else. So everyone else is R dash dash. Okay, so we have 3 sets of permissions for each of these different files. Okay, so there's just a look at the permissions themselves. So as a reminder, if it's just a dash, then it's a file. If it's a D, it's a directory. They come in groups of 3. So the first 3 are the user's permission. The next 3 are the group's permission, and the last 3 is everyone else. Okay, what we're going to do is we're going to have a look at changing permissions. Now, when we change the permissions of files and folders, it's actually quite useful. In particular with Linux, the way the file system is set up, you might want to create a new website and you would have to allocate the appropriate permissions for the anonymous user to actually browse and access the contents of the website when they're looking at it on an internet browser. Or you could just be wanting to secure an area and not allow people access to certain files and folders. So each of these 3 permissions, so each of the groups can have read, write, or execute. If you want to give them a read permission, you give them a value of 4. If you want to give them a write, you give them a value of 2. And if you want to give them execute, you give them a value of 1. So if we wanted to give our group read, write, and execute permissions, the value we give them actually 7 in total. If we want to give them read, write permissions, the value is 6. If we want to give them read and execute permissions, the value is 5. If we want to just give them read permissions, the value is 4. And if we don't want to give them anything, the value is 0. Okay, so some examples of this. So we have chmod. Chmod is the command that we would use to change permissions on a file. So chmod 777. So number 7 indicates that read, write, and execute permissions are being given. The first 7 is for the user. The next number here, the next 7, is for the group. So they also have read, write, and execute permissions. And everyone else also has the 7. So they also have read, write, and execute permissions. Then underneath that, we've got another example. This time, chmod 774. So the first 7 would indicate the user's permissions. So that is read, write, and execute. The next 7 here indicates the group permissions. That's read, write, and execute again. And the last one here, the 4, that's everyone else. So 4 would indicate read permissions only. Another example, chmod 664. So the first 6 here indicates the user's permissions, so that's read and write. The next 6 would indicate the group's permissions, so that's read and write again. And the 4 is read only, and that is what's been given to everyone else. So the last one here, chmod 660, file 1. So the first 6 would indicate read and write permissions for the user. The next 6 would indicate read and write permissions for the group, and 0 would indicate that there are no permissions given to anyone else. Okay, so these are just some examples of using chmod. Okay, so in this particular example here, first thing I've got is ls minus l. So that just shows me the current permissions that are here for the files that I've copied across. So the files, because it's a dash, the first 3 here, read, write, dash. So I have the user, I have read, write permissions, the group has read permissions, and everyone else has read permissions. So the example here, chmod 777 computer.txt. So we're changing computer.txt and we're giving read, write, and execute permissions for the user, which is the first 7, for the group, which is the next 7, and for everyone else, which is the next 7. And it's going a pretty green colour for me to indicate that it's an executable file. Then we have chmod 660, and we're doing this to file 1. So 6 is for the user. So 6 is read and write. So you can see that for file 1, read and write. And then we have got 6 again for the group. So that's read and write also. And 0 would indicate no permissions for anyone else. The next command here is chmod 740 file 2. So we're doing this on file 2. So we're changing the user's permissions to 7 on file 2. So that's read, write, and execute. We're given the group 4. 4 is read only, as you can see. And everyone else gets 0. So they don't get any permissions. So all that's happened here is we have 3 sets of permissions that have been altered. 2 of the files have become executable. We can see that because they're a pretty green colour. Okay, so that's permissions. Have a look at the exercises on permissions. If you've got any issues, let me know. The next one is sort. So we can do a sort on the contents of a file. Okay, so a simple sort is sort, and we have a file that we copied across called OSI. So sort osi.txt sorts everything in alphabetical order, as you can see here. And then we have got another example, sort computer.txt, and again that sorts everything in alphabetical order. The next one we've got here is sort file1. So there's a wee bit more information inside file1. It's got a few different columns, and you can see that it's sorted the information here, and it's sorted it in alphabetical order. So it's just a wee simple sort, and all you're doing is you're looking at the contents of the file that have been sorted. There are numerous file options when it comes to sorting a file. We might want it in reverse order. So if we do it in reverse order, it's -R is a switch. We might want to ignore blank lines, so that could be -B we use. Or we might want to sort on a particular column that's not column 1 because it defaults to column 1. So we can use -K, and the example here is 2, so that would sort on column 2. So looking at the command I've got here, I am sorting file1.txt. I've got -R, so I'm doing it in reverse order. And then I've got -K4. So the 4 would indicate that I'm doing it on the 4th column. So if we count across 1, 2, 3, 4, it's actually on the year of manufacture. So it's in reverse order, so highest first, so 2000, 1999, 97, 6, 5, 4, 1989, and so on, all the way down. Okay, so you can sort on not just the first field, but you can also sort on different fields, and the option for that is -K. Now, as far as printing goes, we can't print. There is no printer attached to the remote server, so if you're ever asked how you complete a print command, you can type in or the command in the answer box, but you can't actually do it apart from one command really, I suppose. ls, the greater than sign. So remember, the greater than sign is the redirection. If we were typing ls in on its own, standard output would display it to the screen. This is the redirection symbol. So all it's doing is it's sending it somewhere else. Previously, what we done was we put it in a file, but we can also send it to the printer. So LPR line printer, it won't work. There's no printer. We can also, if we wanted, send a file to the printer, LPR space file1.txt. Again, there's no printer. This is not going to work. What you can see is you can see LPQ. So LPQ will show you the jobs that are listed in the printer queue. So all the jobs are sent to a printer queue, and we have this thing called a daemon which comes along and takes the first job, prints it, comes back and gets the next, and so on. If we wanted to delete a job from the print queue, you could use LPRM and then the number of the print job. You'll get the number of the print job from the print queue. I don't think you're able to do this unless you own the print. I can do it because I'm logged in as administrator. So here we go, we've got LPQ, so that shows me all the jobs, and it shows me the size, and it shows me the job number and who done it. Then I have got LPRM, and what I'm doing is I'm deleting job 2. This sudo thing, I have gone in as super user. It's the administrator, so it just forces the deletion by temporarily elevating my log on status to admin. Okay. Right, using find. Sometimes it can be useful to find files. Sometimes you won't have permissions possibly to read the files and folders in certain directories as well, so you might get errors when you do this. But what we can do is we can use find, and you can use -name. So that'll set the name to be searched for. So you could say file1.txt, Another useful one here is size. Um, what you can do is you may well be, as an administrator, providing users with somewhere to save their information, but some of them may well be using too much space. So you can run a command that checks the size to make sure no one is over limit on the size of files that they're actually saving. So that can be a useful command if you're a system admin. I'll show you an example. So we have find and slash. So we're looking at the root directory, and we've got -i name. So we're ignoring the case, and it's file2.txt. If I was to type that in on its own, I might get error messages from folders that I'm not allowed permission to access. So a way around that is have a space, then 2. If the search returns a value of 2, it means there's an error. So you can catch that and you can say 2 greater than. So we're redirecting anything that comes back with an error message, and we're sending it to dev null. What dev null is a catch-all for system errors, and it just ignores them, so they go away. So this is just a search of everyone's file system to find out who has got file 2. Okay, what you can also do is, instead of actually displaying that on the screen, if you're searching for something, it may well be that you want to store the information. So what we can do is type the same command in again, and instead of it displaying on the screen, we can use the greater than sign and then output.txt. And all that's doing is it's creating a file called output.txt, and instead of all the results of that command showing on the screen, it gets placed in a file. So you can see I've done ls here just to prove that output.txt has actually been generated. Okay, so the next thing I'm going to have a look at is processes. Whenever you start a new task, you start a new process. So to see the processes that are currently running at the moment, we can use PS. Okay, so at the moment I've typed in PS and it says there are 2 processes running. Okay, it has this thing PID. So PID is the process identification number. So the system gives all of the different processes an ID number. Okay, so that's a list of the processes I have at the moment. Then I have PS -AX. What that's doing is showing me everything. So it's showing me all processes running on the system at the moment. It's quite long. This is just a snapshot. So it's showing me the system processes as well as my own processes. What we can also do is sometimes some tasks can take a long time. If, for instance, you were going to back up a system, a backup of a system may well take a long time, depending on how big the system is and what type of backup you're doing. So what you can actually do is you can force this background, force the command to run in the background. Normally all commands run in the foreground and you get an automatic result. But if we force it to run in the background, what happens is when there's any free space and the system's not being used, it will execute this background process. So if you put an ampersand sign, what you can, at the end of a command, you can force it to run in the background. So here I have the find command again, and the only difference here is that I have this symbol at the end here. So that symbol would denote that this particular command should run in the background. Okay, so it's running straight away, as you can see, but that's because nobody else is using the system at the moment and it's free, so it can do that. What we can also do is we can stop processes early. We've all done it. We've sent a job to the printer. We don't want to print that anymore. Go in and delete it. start a command and then you think, oh no, I've put the wrong value in, I don't want to do that anymore, and you stop it. So if the command is running or if it's scheduled to run, sometimes we have to force it to stop. So the command to force it to stop is kill -9. So that's the command. And this is a pretend process ID number. So I've just put 1, 2, 3, 4, 5. So kill -9, 1, 2, 3, 4, 5 would force the process with the ID 1, 2, 3, 4, 5 to stop. Okay, so what we're going to have a look at is creating another terminal. Now the reason I'm doing this is that so you can actually play about and you can create another terminal and force that terminal to close using the kill command. Okay, so there are a whole series of commands that we have to set up for our new terminal. So what we'll do first off is we'll show a list of the users that are currently there. So I'm just going to move across. I'll explain it on this window. So PS -U. So that's showing me all of my particular user processes. So it's showing me the user, it's showing me the process ID number, the CPU used, the amount of memory used, and so on, when it started and what the command is. Okay, the command I'm going to use here is tmux. So what tmux does is it will open up another terminal window. So it opens up this other terminal window, and once we've got the other terminal window open, we'll come out of the terminal window and we'll go back to this screen. So when you're in the new terminal window, if you press Control B, so that's Control B, and then once you've done that, hit D. And what will happen is it will take you out and it will bring you back here. And it will say detached from session 0. So we're out of it, it tells us that, but it's still running. I can see that it's still running because I've got PS -U again. And having a look here, I have got a new window. So I've got my command PS -U, that's fine. I've got the current process, that's the same process ID number, that's fine. I can see that I have got a new terminal shown here. Okay, so the process ID number for the new terminal is 9925, so that's my particular one. It's showing me the CPU usage and the memory usage. So what it's done is our original shell that we type in is a bash shell. So it's created another bash shell. So we need to close it down. So the command to do that is kill -9, and then I'm just going to take that process ID number, put it in here and hit enter. And then to verify that it's gone, PS -U. So it shows me here that I've forced a particular running process to go away. Okay. Right, so I'm just going to have a look at some just general file system commands. Okay, so if I want to see disk usage, I can type df. So that shows me what's used and what's available. If I want to look at my directory usage, I can use du. So du will show the user space directory usage. And then free, what free does is it shows you the memory usage on the system. And then you've got who am I. Sometimes you can temporarily log in as someone else. So who am I just tells you your username. Okay, so we have the username shown there. And then the last one here is date. So date will show you the date and time the system that you're using. Okay, so that's just a wee snapshot of what we have done in class. Any questions, just ask.